let's go back. So our key development is, of course, the Ivision software. Whatever you see with from EVP, it's always the same software platform. Whatever hardware you use, that's important to understand why I speak always about Ivision software. And of course, what we started maybe a few years ago is to develop specialized hardware for different stuff. You will see it in a few minutes also. So we sell the Ivision product to make it easier for our customers, mainly as packages, as you can. So we have these packages you can see here. Whatever package you buy, you are free to add all the tools which you can find in our price list. So, for example, you can always start with a basic package. Of course, it's the cheapest with the lowest function count, and you can add functions you need. Or it's more calculation basis, or you use a package which has all the functions you need. In some cases, it's cheaper. But we made it to make it easier for our customer to make a solution. Therefore, we have the thermal imaging, Ivision Thermal. For thermal imaging tasks, there are all the components to do only thermal imaging. But as you will see, you can do much more than thermal imaging, because a lot of functions are also available or can be used with the thermal imaging, which are not typical thermal functions like OCR reading. Of course, you can read OCR from warm patterns. And finally, we have also some smart cameras in which the Ivision software is running. And you will see in a few seconds this packages. So we have also a thermal smart camera. So you can do thermal imaging in a smart camera. And as a combination, and because it's new, we have the deep learning systems, which are available for all the different components. It's separated because it's not so easy to simply say, okay, I buy this for that product. The neural networks which we train or we have to train are not available for all the combinations, and that's why it's here as a separate product. To give you a short and glance to the software and the hardware, you see here from PC with x86 or ARM, whatever a PC is today, with whatever interface like USB, Firewire, GG, or Camera Link, to embedded systems with all these interfaces, or maybe also with MIPI, or finally to embedded systems like a Raspberry Pi, or finally like these smart cameras. As I told you, with the integrated software inside, you can use this exact same software on all these platforms. And to make it easier for our customers, we always do a translation for the software into, let's say, our main target market languages. Therefore, you find these English, German, English, French, and so on. To make it easier, of course, we can do more translations depending if there are markets which need their native language version. So what are the markets? Of course, the markets are all, because normally the software doesn't care about if it looks to an automotive part or to a semiconductor or electronic or pharma part, even food, beverage, or whatever. It's always similar what to do, and therefore you can use the software also in these markets. At the end, it's mostly something detecting, matching, or code reading, and I think you could imagine that you can make these solutions. And of course, normally we try to go to a lot of exhibitions. So right now this year, we have only really booked the Vision Show and the ITE show and the virtual Automate show in the US. and all the others we will see. Not sure if we will attend them or if we can. There's also an embedded show, which we are which will be virtual, so you can find us there with our embedded products. So let's go to our today interesting. What's that? I think this is wrong. So to our, this is the wrong. I don't know. I think this doesn't belong to this one. Anyway, let's go to the thermal imaging. I wonder. What is thermal imaging? It's capturing images with a camera which is able to detect temperature. So this is, it sounds easy, it's more complex, and of course for a simple application it's very easy. Simple applications like here the passive thermal example which I have here. You see the Ivision software which you saw before, and you see here for example from 2 thermal image cameras the captured images and the temperature at different points. It's only that you have an idea what our target is today. So you can see it live in a few seconds. And that's, I think, more interesting than have this screenshot. But it's not so boring. I simply decided to show this to you. I wanted to show you, I think, this for maybe it's in this presentation. Yes, so we have the overview over the. So the first thing would be only that we have a structure for today. This was what's wrong on the other presentation. I don't know why this wrong page was in the presentation. We will have a short look into the structure of the software, but then the most important thing is the thermal hardware and some thoughts about the different thermal imaging operations, or how to make thermal imaging. I think most of our customers right now do passive passive thermal imaging, means the part you inspect dissipate heat. But of course there are a lot of other options like impulse and lock-in thermal imaging. And of course then we do some first steps. So that's what I missed here before this first image. Maybe first glance to the instruction set, or the important instruction set. Of course, as always, and that what I said yesterday for all who attended, we have always the same tool for everything, so you don't have to think about how to capture an image from a camera. You use the capture image tool, and it will capture. In this case, if you have connected thermal image camera, you get a thermal image. And these images are right now from the available cameras in 16-bit images, means information is stored in 16-bit. So to make it make some stuff available besides the real temperature evaluation, which needs really the temperature, we also have some filters to convert these thermal images into 8-bit gray image. At the end, if you look to a thermal 16-bit image, it's also a gray image, but it's with a 16-bit depth, and it's difficult to display it and to handle it. So therefore, we have this conversion to the standard bit size, which is enough for a lot of stuff. Then we have a short look. We have only a few thermal imaging tools which are enough to make all these interesting interesting solutions, also for impulse login and passive imaging. And finally, yes, this is a combination of thermal and color image. It's sometimes interesting if in case you don't have the information in the 16-bit image, because maybe you need some structural information. Or I have a very nice example where you can use this combined registration of the cameras. And also we can look to any of the other 2D tools you will see. And for example, here we have this tool. So we have on one side, we have the thermal image with all the temperature. On the other side, you see our evaluation, where you can define the hotspots, and you can also track the part. If the part is not on a certain point, so you can track the part and do within the tracked part. That means if it moves in this in the field of view, you can do then always on the right part position the inspection about the temperature. Therefore, you can mapping any of the supported thermal cameras with the true gray or color image. We, especially for some applications, we made this. You see it on the bottom line. You will see it later. It's called Hydra. It's a hardware which we made, and some details I can explain you in a few seconds. But before we start, we should think about thermal imaging. I think maybe most of you have some background in thermal imaging, but you should always think about, before you say, okay, I buy a thermal camera and do some thermal imaging, what is the background, and is it working? And therefore, one of the most important things is the surface coefficient of what you are looking for. This means what do I see later? Of course, if you have fully passive thermal imaging, means you have a part which emits light, not light, temperature, then in most cases you don't have to think about it. It's an easy case. But even if you have an emitter, and the emitter is based on a metal part, and you look to the middle part, then you have to think about, do I see what I want to see? Means if the middle part emits temperature, but for example, if you have aluminum part which is not which is very milky, it has not a high glossy surface, and you look to this part and you see 3 hotspots, and you know I have only one heat source behind the part, then you think maybe the camera isn't a defect, but in most cases the problem is because as a human eye, you look to this part, you will realize there is no reflection, of course. But in reality, the heat wavelengths are reflected from this part. So sometimes you see yourself as a heat spot on that surface, because the heat is reflected even from that surface, or any other heat source which is within the field of view. That's why I have this small picture here to give you, before you start, before we start with the evaluation, give you some ideas what you should think about it. Because if you don't think about it, it would not work. Or you would think, why does the software does so crazy things? At the end, it's not software. These are reflections, and maybe you're looking for a very low heat source, but in reality you have behind of your part maybe a lamp, and the reflection of the lamp heat source would result in what you see, and not what result in what the camera sees. You don't see it, and that's a major problem in most solutions of thermal imaging. So before we start now, we will have a look to the currently supported smart thermal cameras. So we start with automation technology for some reasons. They made nice camera, and we also support their 3D cameras. It's a Geek E compliant GenTL camera, which makes it easy to integrate. So if you have any other Geek E compliant camera, that would also work. For example, also the DALSA thermal imaging camera is Geek E compliant, and the integration was very fast. Finally, many of these new thermal imaging cameras are Geek E compliant. So we could, and therefore you could use the complete series. If there are more than one camera, you simply can use it. Or we can adjust it very easily that it works with all the series, camera series. Of course, there is another company, it's called DST. It's not so well known, but they make nice camera modules. And then we start to make our first also thermal cameras or sensors based or driven mostly from customers who had the need of a special thermal camera with some additional or maybe a very low price or low resolution thermal camera. So the software works not only with the, let's say, high-res cameras, thermal imaging cameras. The interesting thing is here also what means high-res. The interesting thing is what you have to have in your in your mind for thermal imaging cameras. High-res starts is 640 by 480. This is very high-res. So the average cameras are between 160, 120, up to 640, 480. That means so 640 by 480, the very old standard for gray cameras from, let's say, 25 years ago, is the high-res standard for thermal imaging. And due to the very slow process change, for it's enough to do solutions. What I told you before, we made a 320 by 240 camera here with a color camera to make some special solution, especially during the Corona times. So we have this combination from on the left side or upper side, you see a color camera. On the right side, in the hole, there is a special lens for the thermal imaging camera to capture fully ready registered two images for high-res color image and thermal image. And we can run, because inside of this camera is either Xilinx, two options from Xilinx, the slower one with 800 megahertz and the faster one with 1.6 gigahertz to operate on these two images. So you have fully autonomous camera to make thermal images with both pictures. Where it makes really sense, you will see an example very soon. And of course, we made it for industry, so we added the IP65M12 connectors, and we have, of course, integrated I/O and Ethernet to simply integrate this camera into complete systems or to make standalone solutions. And of course, we support all the major, I would say the market leader in thermal imaging cameras, FLIR. So you can use all the FLIR cameras with all kind of resolutions and cooled and uncooled cameras. So I think you have the widest range of thermal cameras here. And of course, we also support Optris. It's a It's a German manufacturer with also a series of cameras up to 640 and different spectral wavelengths. This is a nice set of cameras with which you can start. What we do support is an easy integration of other thermal imaging cameras. So we work on that if there are other camera manufacturers which have a nice camera, or customers who say, okay, I want to use that camera, we can do it very fast, as we do it for all other hardware which we are supporting. And finally, we have also an additional small device. We call it thermal controller. So if it's not passive, you have to control the thermal devices. Either if you do pulse thermal imaging, you have to generate pulses. If you do lock-in, you have to generate multiple pulses in multiple different time frames to get these phase shifted pulses. And also for some passive thermal imaging, it's nice to have, for example, thermal reference. That means it's a black body which is controlled, and from which you know, okay, this black body has that temperature, to know exactly what the temperature around your part is. So we have this ready-made thermal controller which does everything with the Ivision software. So it's also integrated in the software, so that you don't have to say, okay, how to start and stop a heating source. Everything is done here from this controller, also controlling that that this black body has the temperature which we expect to have. And this is a nice controller. I think you can get it also from some other manufacturers. Mostly these controllers are sold by the manufacturer of the cameras. So that's one of the reasons why we said, okay, we build it by ourselves to use it with all the other cameras, because it's always the same thing what they are doing. And of course, for lock-in thermal imaging, it's really important to control the image capturing process very thoroughly. So that was the, let's say, a fast intro into the hardware. If there are any questions, feel free to ask me, or you can write me also. We saw it on the chat, so that I can answer you some questions. We can also do it after we finished our webinar from today. And now let's say what are the thermal evaluation with Ivision. As I told you, we have one software which works with all the hardware which we support, from line scan cameras to 2D gray and color cameras, to thermal cameras, to 3D all kind of cameras, as I mentioned yesterday. And also we support hyperspectral cameras. So for whatever camera you have connected, you only need at the end, 1 second. We lost sound during this, the max frame rate of the login module. There's no principal limitation, but we can run this module, the login module, with maximum 20 kilohertz. So this is what we needed for the moment. So right now, this is the specification which we can control, but we don't have a heat source which can do it with this speed. We tried it with some lasers as a heat source, works very well. But even a laser with 20 kilohertz is So the cameras are not so fast that it's really needed for the moment, or we didn't found an application where we needed it, but we designed it to meet, from our perspective, all speed constraints to constraints for the lock-in thermal imaging. Yes. So, and what we have, of course, which works directly with this, also with our thermal controller together, is the Thermo capture sequence. It doesn't need the controller. For example, if you have a process like forming the dashboards, so the process has by itself process heat, and you could do this, let's say, impulse thermal imaging direct after the part comes out of the forming unit, and run the impulse thermal imaging. So of course, in this case, we use the controller as a reference to be sure that the form has the expected minimum temperature to meet the needs for the lock-in thermal imaging. So it's really nice to have it, because sometimes you need this reference, especially if you have impulse thermal imaging. And of course, you say, why do we need this reference? Simply, sometimes the process stops, and the part which was made comes out of the forming unit after maybe 2 or 3 minutes when it's cooled down. So if it comes then out of the area and you use the cooled part, of course, the result is wrong, because you don't have a cooling curve at that point, or the wrong cooling curve. And in that case, we have this black body in the camera area, which has the reference temperature the form should have after the process. So we can see, okay, now it's much too cold. It makes no sense to make even an impulse cooling analysis. So these are the only tools you need to know to do image capturing. And then you have how we name it, data streams in the main memory. Data streams are any kind of image data which come to the Ivision software. I mentioned it before, we name it EVHD, and normally what it's missing here is VIC. I removed it because this is a name from the very beginning. VIC comes from video input channel. Of course, the thermal imaging camera is not a video camera, but yes, we still stay on this. Else we would have to remove all the naming conventions. At the end, it's right now this VIC delivers a data stream from a camera into the main memory, and all the algorithms work on this data stream. And the difference is between capture image or asynchronous capture image. It simply captures multiple images. Either it captures it and waits until the capture is finished, or if it's asynchronous, it captures it and you can do something during the capturing is working. On many machines, it's okay. So with the asynchronous tool, you could do also a kind of capture thermo sequence, based on the time constraints to have a good, a valid capture sequence. You need some well-defined time constraints to the impulse controller, and therefore we have this sequence capture tool, which if you have a look to the image capture tool, there is a save image option always available, and because the capture sequence generates a sequence of images or multiple sequences of images, we have also a special storage to store these sequences with all the information needed, especially the face, which is used in the controller to get first of all to know how to operate with cosine or discrete cosine transform on these frequencies. So this is the background why we have this also capture Thermo sequence, because in some cases you need additional information and you don't need only one image, because what we want to do is we want to run these examples also offline without the camera, or to analyze it or to help our customers to make the solutions. And of course, finally, here we have this example for, let's say, multi-thermal and color image. In this case, you see the color image from our Hydra camera on the left side, and on the right side, you see the thermal image. And what we are doing here is we use our deep learning network to detect the face. And based on that, we do the evaluation. You see it in the thermal image. You see we do the evaluation of the temperature in the center of the eye and in at the head, the forehead, to get different temperature zones and different temperatures to know what the temperature of a human is. This is, of course, you can do it also with your thermometer if you are at the entrance, but this can be used on automatic entrances. As I told you, this is the Hydra with the PLC-IO, which generates automatically also release gate, so that you automatically can stop the entrance for people. And but on the back side, it's always the Ivision software. And of course, you don't have to use the Hydra. You can use also any other camera combination, like FLIR and Basler, or like FLIR and Point Grey, or FLIR, like I want to say today. And of course, I have this one here because this shows also what the software can do. And this is only done for as an example. We have this. We have the built-in web server, which is available always for all applications. And of course, you can send out also the results of the thermal. You can also send out the thermal images, but in this case, for example, you can send out it to a mobile device, only the color image with the person and the measured temperature, so that you can speak with the people who are at that point to see why they are here with this temperature. So I think this was a rough overview about how the Ivision software works and the insights and the hardware. If you need any special hardware, feel free to contact us. Means if you have another thermal camera where you say, okay, this is much better and we want to use it, we can integrate it. It's not a problem, as long as it has an interface and the manufacturer opens up the interface that we can capture images from that. Yes, now I would say let's go to the Ivision software to see how it works and how you can use it. So I think everybody should have the download link, and what everybody also should have is the all the project files. I just come back to the project files in a few seconds. So you should download everything and install the Ivision software. After you have installed the Ivision software, you should have these two icons on your desktop, or if you don't have it because you denied to put it on the desktop, you can go to the installation folder, and you will find the two icons also here. And another important tool is the hardware configurator, which is really important because due to the support of all the different hardware, you can select which hardware you want to use. And this have to be done at least once when you install the system and you select the camera, or you have to do it all the time if you change the camera. And of course, as you saw, you can combine color cameras with thermal cameras, with 3D cameras, or whatever. There is no restriction. So what you first have to do after you have installed the Ivision software, you go to your installation folder and you start the hardware configurator. And of course, then you get this message because we do some changes in the main folder. With the Ivision 4, you don't get this yellow message again. For my webinar, I use the older version of the Ivision. And here you will see, of course, all the supported camera hardware. And of course, if you want to use the DALSA, because DALSA has one unified driver for all hardware, you simply select DALSA and you follow the description you find here. And if you follow this instruction, if you did this and apply this setup, after all, the camera which you have selected, so in this case I selected DALSA, but you could also go to let's say FLIR, and then you will see, okay, it works also with FLIR, or with if you go to Optris, you can use Optris. Or if you have GeniCam camera, you can use also the GeniCam interface. For the moment, I think there is no direct support for Windows, for the Windows driver. But if you want to test the software with any, let's say, gray camera, maybe you find also a supported thermal camera for the direct show driver for Windows. Or if you have installed the software, I mentioned it before, you can use the software with on x86 systems with Windows or Linux, and on ARM platforms you have to use Linux only. For the moment, we support on ARM platforms only Linux. So you simply select what you need. For example, in this case, you use direct show, and you can use offline. Or for example, if you have the Hydra, or I think also the Optris has an output, or FLIR has also, as far as I know it for the moment, you can use camera as I/O device. This is a PLC I/O device, means direct I/O lines, 24 volts. And you say apply, and then you can use this hardware device for your tests. So even in the demo version, everything is working. Besides these PLC I/O, of course, we support all these major network I/Os like Profinet, Profibus, Modbus, OPC-UA, MQTT, and TCP/IP, UDP RS232. So additionally to this, you can use all of this I/O. But in many cases today, or if you have a small solution, a small PLC I/O would work. So maybe to give you a short idea, we also have this iMio. This is a very small unit. It's with 4 input and 4 outputs. We added the last few days a new iMio. It's called iMio PLC, which has more I/Os. So this would also work, but feel free. You can use also the Beckhoff I/O, or the VNT. I've forgotten the supporter, the hardware manufacturer, or ICP, or Adlink, and some others, which simply work with the software as a real PLC lines, 24 volts operation. So after you have done this, you can start the Ivision software. Of course, if you run it for thermal image, for the normal cameras, which we saw in the very beginning, like FLIR, DALSA, AT, Optris, and so on, you use the Ivision software. if you use the Hydra system, you use the remote programming, because the Hydra system is not a thermal camera, it's a smart camera. And the smart camera runs the Ivision software inside of smart camera. So the programming is done from your laptop, but all the programming is done automatically inside of the remote device. This belongs to all kinds of remote devices. From the very beginning, you saw from the first presentation, I think you remember, we had, no, not this one, we had also these smart cameras here. All these smart cameras, or let's say all the smart devices, are programmed with the remote Ivision software. Remote, if I can start it, that you have a short glance to the remote system. You can see it looks similar to the normal software. The major difference is here. First of all, you see it here. You see here the remote interface, and if you go to the option menu, the configuration opens, the device configuration opens up, and you can connect to your remote device which you want to control. And if after connected, all the information is transferred to your programming device. That means it's transferred. First of all, the images are transferred to the programming environment, and the programming is directly transferred into the device, so that the device can autonomously, after you do disconnect at the end, it can run autonomously without any laptop or anything. It works completely without this. So remote devices could be smart cameras like the Hydra or any other, but it could also be a small embedded system which you can use. So, okay, then I would say let's start with our normal Ivision software. And as you can see, also for this webinar, I used the standard demo mode. So, one moment, I have to move this anyhow. Okay. So, okay, so sorry, I think you couldn't see it, but the Zoom controller was in my field of view. So what do we have? We have our toolboxes. You saw some of them in the presentation before. So of course we have the terminal toolbox and all the others. Then we have the program editor, and finally we have the camera viewer. Not sure how far you know the Ivision software, but the programming is always done the same way. You go to the tool you want to use. For example, in this case, you use the capture tool. You add the capture tool to the programming editor, and then you have to configure the capture tool. And then, for example, if it's image capture, it offers you the option capture the image from the connected camera. If it's a thermal camera, you get a thermal image. If it's any other, it's any other image. Or you have also the option to save and load image. And of course, it sounds not so important, but of course, it helps us to help you later. If you do a new solution, the first thing what you should do is capturing some real images from your machine or from your task and store it. That means you need 2 times the tool. You need it once with capture an image, and of course you need the tool again with save image. And there you can do it continuously with timestamp, and of course as long as it's any kind of gray image. Gray is also a thermal image, a normal thermal image. You could use this, take here the PNG. This is can store a 16-bit image, and it stores now all the captured images with test, and then date, time, the time and date code, so that you can capture as many as you want, or as much it fits into your hard disk. The real important thing is, in this case, that at the end you have in your project the files you need, or you can send to us. So what is a project? That's really, it sounds like nothing, but it's really important. I would say, let's say we start with we start with a thermal project. So let's say we use the tracking example here. We can have a look to some others, and of course this shows you also what you can do. For example, that that you can give a customer or a user a different user interface. So this is a kind of user interface. You have a lot of options, you have statistics and everything, or you run it, or you do it as a runtime. Then you can run the Ivision in the background and only use the image memories to display what you are doing. So this is a project, and a project has, for example, different user interfaces. So we have now, in this case, the simple process. You see, the if you look to this this layout selector, you can change the names and everything. So if you do this demos, mostly don't take so much care and keep the names as they are. And of course, you can simply change to the development mode, and then you are back, as you can see, in the normal programming environment. So you see now, of course, here are the image capture tools. Here's the image capture tool. For, let's say, for the original one, we use the active Thermo capture to load the images. In this case, we use load image cyclic, and then we use the complete folder. So each time we execute the program, so you have here the complete program execution. Maybe for all of you who never used the Ivision, we do a short intro to the Ivision tool and user set. So you have here the different tools, and so this is a cyclic execution. It runs as long as you stop it. Or you can do here a complete execution, and you see here now the part is moving, and with the moving part we do move also all the heat inspection areas, so that we inspect always the same areas which are interesting in this case. And of course you have also the single step option. There you can see for each command what's going on and how we do the different measurements. So this is normally how you do the programming and how you see if it works or it's not working. You select the tool, for example, for image capturing or for loading it again, and then you use the tool for example here for the thermo measure to measure a temperature or whatever. And so on, and at the end you have this let's say thermal evaluation solution. So in this case we see we have 1, 2, 3, 4, 5, 6 spots to measure a temperature in on this PCB. Yes, okay, so that's what we see. So you can also, this is a single step. As long as we are in operation mode, single step is also operation mode, you can stop the execution, then the program counter will go back. Or you can also say, I want to only execute these 5 commands for what reason ever. then you can use this one. Then it executes exactly these 5 commands, and the program counter is on the next position. So this is for the programming really comfortable and really nice. To explain some of the other stuff, I would go from here on the top here to explain the rest. The next one is you can save the program with this here. Sorry, you can make a new program. To start with a new program, you can open a program which is stored. In a few seconds, I explain you why we have why about the project. This is interesting. And here you can save the program. Of course, it's with a small. For all the people who are not very new, this is a disk, a small floppy disk sign. It means store it on the floppy disk. Or you can delete the current program or close it. And then it's deleted from here. If it's not saved, it's gone. If it's saved, then it's only removed from the list. You can open up multiple of these programs at the same time. So, for example, you can make also subroutines. Maybe you make one program who captures only the images, and one subroutine who does do the evaluation, another subroutine who does the I/O handling, and so on. To control the subroutines and everything, you have the interpreter control. Here you have the calling subroutine program to do subroutines, or you can also generate jumps in case of good or bad. I can mention it in a few seconds also. The next important thing is here, it's called configuration mode and process mode. And of course, you see here the debugging feature. This belongs to the E column here. And if you go to the E column and you press the right button, you see here a lot of options. So this red stop bar means never. Don't execute this command. Or execute it always, then you have this gearbox. And in all others, the commands are executed only in configuration mode or only in process mode. And and then you see, or only in debug mode, then it's you have the process mode and the debug mode. Then you can say, okay, if you can add to your program some debugging stuff, either for the configuration mode. That means you want to see some results. If you have 1,000 images and you will only see some special results, you can add these output lines to the code, and you can say in configuration mode and debug mode, please output these results. And this makes debugging much easier. And or the other way, if you have a process mode and you say, okay, if this happens, I need a message, or I want to store the information about this error, then you can also add this debug mode to the process mode, and you store only in that case the things. It's of course, if you have these small programs, it's not really necessary to do all this debugging. Maybe also if you have 1,000 images and you think how many of these thousands, or if you store the complete set of one day work and you want to look at it at the end of the day and you want to see only the ones with the errors, you simply activate the debug mode and say, okay, only if an error prints this, then it's very easy to handle this kind of debugging. So that's what I really can suggest. The important thing, or why we have this, is, of course, the process mode is normally if you are at the machine, and then if you're at the machine, you want to capture the image from the machine, and if you're in configuration mode, you don't want to capture the image from the machine, because mostly but it depends on how you do it. Mostly you say, I work on stored images. And to be sure that it's automatically changed, so you could also go here and say, this is only in process mode, and here only in configuration mode. So you see a small P and C in this column. That means these tools are only executed in process mode. That means if this changes to process, and this, as long as we're in configuration mode, this one is executed in configuration mode. So you don't have to think if you go to the machine, if you press process mode or you have a different mode, then immediately it switches not only to capture image from the machine, maybe you have also all the I/O, PLC I/O, which is connected to the machine active, because you say, if it's in process mode, please handle also the PLC. And of course, if you are not at the machine, if you are at your programming environment, sorry, in your programming environment, you don't want to have the I/O coupling, because maybe you wait until the machine is ready and you have a loop there. You would wait forever. There's no machine, no I/O. That's why we have this, so you can easily switch between these modes. Because we are not so careful about everything, I have to switch it off, because if you go to process mode, we still want, because we don't have a machine here, we still doesn't want to have this, so we want to have always the capturing for this demo from the file. So, but it's really helpful if you really work on a machine. So that's for what this one here is. If you have a camera, you can do some live images here, so you don't have to make a program or anything. You connect the camera, press the live button, and you get immediately a live image from what camera you have. If it's a thermal camera, you get a thermal image. If it's a gray or color camera, you get a gray color image, and so on. Whatever is connected, you get the image here, point cloud or whatever. And with the next two, it's controlled if you do the image capture triggered or with a flash or both, especially if you have everything connected to a machine and the part is moving. So you only want to make images or capture images, even for adjusting if a part is under the camera. And so you can simply activate the trigger, and then also in this mode you get only a new image when a trigger is initiated. If you simply use it without trigger, you get the live build right away from the camera. So these are the main control buttons here on top. And of course, we saw this first column, the E column, and how you can control the E column in conjunction with the configuration mode and debugging mode. Let's have a short glance also to the first column. This allows you to do debugging, the normal way of debugging of any kind of software. You can go to one position here and you can say, I want to have a breakpoint. So that means if you execute it now, the tool stops exactly at the breakpoint. So you have different options. Breakpoint on success, that means you can say if this tool is successful, we do a breakpoint, or you want to have a breakpoint only if the tool has an error, or if the tool has a warning, or on a total failure. Total failure could be if, for example, of course, if the image capture is wrong, then because the camera cannot capture an image, then it's an error. But if the camera is disconnected, of course, this is also an error. But this is a failure, because there is a major problem right now. So you can, if you have sometimes this error and you want to, it happens only maybe once a day, then you want to see what happens then. So we just had it. For example, there was a cable where one of the cables inside were broken, and it works nearly all the time. Let's say in the average, it works 23 hours perfectly. And once there was no image capture, but mostly you couldn't get it because you was not there. You only saw, okay, for one reason, the camera disengaged to the system, but the robot simply go ahead because he didn't realize it. And so we could do a break on failure and do a special handling then, so that we can stop everything. And we saw, okay, it happens always when the robot was at a special position. And then we could realize very easily, or the customer could not be, the customer could really easily see, okay, maybe it's a cable, because in all these cases, because the next time it works again, that's a dangerous thing, because in all cases the robot was at the same position, and you could say, okay, let's remove the cable and see if it works then. So it's a really nice debugging feature. You can use it, and I think it's very helpful. I could really suggest to use it, and I think you will do. So we have another column, it's called G for graphics. Graphics is all the overlay. So you see here this green line from the key match. It's a matcher who searches for the object. And in that case, if you use the right mouse button, you see the options. You can say, okay, we want to see the graphics always. We want to see it only in OK or not OK or never. Depending on what you are doing and how many overlays, in some cases, you say, okay, I don't care about this overlay in any case, or I want to see this overlay only if the tool goes wrong, that I see, that tool went wrong. And finally, if you have a machine which is, you have a not so powerful system, it helps you to save some CPU power, because at the end, the overlay drawing needs CPU power. So of course, if you have a x86 CPU from, let's say, after 2015, or yes, maybe also 2012 or so, you never care about this. But as we saw in the hardware, you saw that we also support these ARM embedded systems, also with maybe not so powerful CPUs. There it might be interesting. The same is with the next column. It's a T for text. It outputs a text for each command, which is inserted in this program editor to our log file. First of all, it helps you to see what the tool is doing. The other thing, the log file is a very powerful tool if something is not working and you need some help from us. In this case, we need the information, and so you should always write the log file. To see what the log file has, you can simply activate it, and then you have a rough overview about the comments and what's done, what if the comment was successful or not successful. If it was successful, it's green. If it was not successful, of course, it's red. So for the moment, we don't have a red one. That means all are green. How much information is written to the log file can be controlled from here. As you can see, I have switched on everything. Of course, log files also need CPU power. If you have a normal PC, you can simply don't care about it. Even for the real fast systems with, let's say, 40 parts per second, it's not a problem. But on a smaller systems, you should consider if you switch on or off the text output, and you have the same options like the graphic overlay, either always, on only in OK, not OK, or never, which reduces also the output here, because if you only print outputs, if an error occurs, then you have the error. Of course, these log files are written from the very beginning when the Ivision software starts. And that's why it's also important for us, because first of all, we can see what software versions you are using. But also the boot up version is very nice, because you see here if everything initialized well or if something is missing. And for example, this is my preferred example. Once I had a backup IO module here, and for some reason I simply removed it. But because I only removed it without telling the software it's no longer there, the software tries to activate it, and he says, okay, it's no longer there. So in my case, if I still have, if I still wonder why is the I/O not working, I could have look here and see, okay, the DLL is not there, so no wonder why it's not working. That's why I really recommend, if something is not working, you will find here always the reason. Or for example, I have for some, sometimes I have an RS-232 interface to the PC by USB, and of course right now I don't have it here. So if I wonder why I cannot send out data over RS-232, because it's not connected, and so on. So it's really helpful to have a look at it. And if you want to have support from our side, I really recommend, of course you can call us and say it's not working. Maybe someone can help you, but if you first go write log file and then go to this folder, I explain you where the folder is in a second, right, so that it's fast. You copy it and send it to us, then an engineer or support engineer can have a look to the file and help you in debugging the software, or help you why it's not working. Maybe the camera is not correct initialized, the wrong driver is installed, and so on. All this stuff is part of it. So so we have the text file, the log file. Invert means you can invert the result column. The result column, each tool generates a result. So capture image says good, means we got an image. But if you say, oh, even if it's bad, I want to have a good result, you can invert it. Or you say, I don't care about the result. You simply click to it and you disable it. So we have now these. And finally, we are in the image capture tool, or in whatever. This is a command column. This is important. Here you can either open up the parameter menu for the tool you want to use. If you need information how the tool works, you can always activate the context menu, and if you then open up the tool, you get immediately a complete description of how the tool is working. And what the parameters mean, so you don't have to have everything in mind, you simply can read it immediately. There's also an installed PDF file in the help section under manual, which contains the current manual of the Ivision software, where you can read some more. Especially beside of the left click to the tool, you have here also a right click as on the other side, and then you have different options. For example, you have the quick edit option. The quick edit option means it only opens up the tool without executing it. So, for example, if we go now to this tool here, if I click it with the left button, okay, we couldn't see it now. Let's see the next one. Okay, let's go. So, okay, the next one. So, now we saw it. Each time I click with the left button, all the tools are executed from the top to the current location, so that everything is updated. If you only want to have a quick edit, that means it's not executed, it's only opened, you have this quick edit. This means you can change values, but the predecessor values on which the tool might need access, you have to, then they are not correct. So you can use it only to change values which are not belonging to some other tools which are executed before. So this is one of the right buttons. What's really important maybe is if you go to tool which controls the register. Maybe this one here. Yes, command will not communicate any registers. Okay, but we will this one. So here you see. Let's go to the right mouse button. Here you see, if you go to the show register information, you see what the tool stores where. So this is important for all the tools, also for the thermal imaging tools, that you don't have to think where are which values. The system automatically stores all the values in so-called registers. And if you want to see the registers, you have this data viewer. For example, you have the value register. And if you simply go to the, if you have a look to the value register, of course, we can close the help, online help. Then, and we run it to this position, you see here, we have one match, because we have only one object which we searched. And of course, the object has a rotation related to the trained one of 19 degrees. So this is the information which all the other tools need to know. Where is the part and what is the rotation? Of course, also the position information, everything is in the other registers. You don't have to think about it. It's implicitly stored. This is, you can have a look to our other YouTube videos if you need more details. This belongs to the basic to the first training of the Ivision, how to use, where to store, but only that you have it if you didn't saw this presentation. So what's really important or really powerful is you should have it in mind. This is the how is the English word? The parameter list, and why it's important, because you have access to all the parameters. Let's go to a thermal image tool, because we do thermal imaging. You have now access to all the parameters of all tools, not only from the software, from within the software, but also from any remote system over the for any connection like Ethernet or RS-232 or whatever. And how to access this? You have the option to do it with the pconlan command. This is over any connection which is to the system, or we have a very powerful tool inside of this of the Ivision software. It's called Script Interpreter, which is in principle a basic interpreter with a basic syntax and with full access to all the commands and all the parameters of the software, and so that you don't have to read in the manual how to access, for example, the filter kernel of this thermal inspection program. You get immediately here the snippet how to do in this, how to set the kernel of that filter or whatever parameter it is. And what is important, I didn't discuss it right now, you see here thermo inspection. This is thermo inspection. It uses as a reference the name in the comment. So it's really important if you want to reference one of, to access one of the parameters of this tool, you should name this differently, so that you have, because this is other automatic names and they are always, as you can see, this is thermal inspection, but here you see thermal measure. You should say measure first part or thermal measure first part or whatever, so that it's really unique for that. So this was so far the column, the comment, and the other column is for the input stream. So we see here we run mostly on the first input stream goes to image memory 0. This is this one here with the thermal image. You see it here also with the wrong image colors, and we do a transformation to an 8-bit gray value to do, for example, it's the tracking. For the tracking, of course, we don't need the the temperature. We need only to know where the part is. Of course the tracking tool works best on 8-bit. So you simply do a transfer to the gray image, then you do the matching here, and after all, you do all the special measurements after you have tracked it. Based on the tracking, you will see here the part, all the inspection windows are moved based on the resulting values of the tracking. So far, so good. Yes. The parameter description is not really important. It gives you a short overview about the current parameters. You can have as many image memories as you need, or let's say at the end, as much main memory you have. The more main memory, the more image memories. Of course, if you have these small images from thermal images, like even the high resolution 640 by 480, there is no restriction even on small hardware. If you have, for example, a 3D image with a few megabytes or a few hundred megabytes, then suddenly it's important to have enough main memory before you add more image memories. Yes, so far we are through the program editor. Of course, here we have. You see if you have a gray image, you see the gray values in the field of view. And of course, you can also change the magnification to have better insight if you want to train it. For the thermal images, you see on the right side, you have a 16-bit image here. And either you can use you can activate the temperature scale, and you can also use either the 16-bit values mapped to the gray values, or you can use the pseudo colors, which belongs to the temperature in these different regions. So this was the main way how to program and what to know about the image memories. Maybe if you remember yesterday we had this 3D, then you have suddenly some other options here on the right side about 3D information, or if you have a real color image, you see the color information about it. I think now we can start programming. What is important if we start programming? The first step would be to make a project. What is a project? A project is what you see here, for example, thermo tracking. We called it thermo tracking. Where are the projects and why do we make the projects? So where are the projects? To find them easily, we have this show data directory. Why do we have it? Why we don't say, okay, it's on C, blah, blah, blah. Simply because of course, on Windows, it's clear where it has to be or should be, because Microsoft recommends this. But on Linux, it's totally different. But also on Windows, if you don't activate the hidden folders, you couldn't see this program data folder, because it's a hidden folder if you install Windows and you don't do anything. So that you don't have to activate it, we directly move you where the Ivision data directory is and where we store all the stuff. And one of the major things, it's called right now in 3, it's devices, and the new one it will be called projects. There you find all the devices or projects. Projects are a combination of the program, the images, and all the data you need to do the evaluation. So in our case right now, we have here, if you have a look to the image capture and we go to this to the folder, you see here we are, maybe if we make it wider, you see here we are in devices, the folder I mentioned just, and we have 2D Thermo examples. So this is a subfolder where we have all the thermal demo examples, and then we have the 2D thermal tracking. And in thermal tracking, there's images. So each program contains all this stuff. So let's have a look to that, and then you will see it. So we just said we are in thermal examples, and then we are looking for the tracking. And if you look into the tracking, we find this file structure. If you go back and we look to this one, we find the same file structure. So this file structure is automatically made from the Ivision software when you say generate new project. And we recommend it always, because then everything is together. So we say today webinar Thermo test, for example. And of course, if you don't reset it, he simply keeps up whatever it has for the moment. So that maybe if you reproduce one, you don't have to change anything. It still has the setting and you simply have to store it again. But if you start by scratch, all this stuff is gone and you have to do it by new. The major important thing is we have now webinar Thermo test. And if we go to with show data directory to this one, and we have a look to devices, we see here webinar Thermo test. This is where we are. And if we open up, we see immediately, okay, we have the complete structure. So if you start with a new project or a new thing, what you want to test, and maybe you think, in any case, you should do it this way, because if you have multiple projects, then each project has the program which belongs to the projects, the images, but also maybe configuration data, matching data, or whatever belongs to the project are stored in this subfolder. And that's why we highly recommend to generate projects. And of course, if you, now we don't delete the image memories, that's why you can see it anyway. So let's say I restart the Ivision software to show you how it looks like if you, because this is a new project and we didn't set anything. That means at the end, if we open this kind of project, you will see, if we now say open project and we go to Thermo test and we open this and you see the screen is empty and the folder is empty. Also the background image is empty. So if you make some solution for the customer, you're free to change the background, of course. Therefore, you have the layout editor, and of course, for example, for the background, we have installed for you one of the backgrounds, but you can use any PNG or BMP for your background. And then you simply load it and you have your customized background. If you start with this, normally you should say, because you are doing for the moment development, maybe you say I do a screen. GUI is shorter, and now we have stored that the background here under this name. That means whatever you put here on the user interface, as you saw it with the last, maybe a start stop button, everything is stored with this name. You can have multiple GUIs, so that you can make different user screens for different users. If you activate the user administration, so you can add a lot of users with different rights, so that you can add to each button or each change a user right, so that you are sure at the end nobody changes something without the password he needs, or that without someone who has the right to do it. Yes, so this is our project, and of course, let's make a short project. We need maybe some images because we don't have a camera right now. I would say, oh, I closed it. So let's go to our directory and we simply organize us some thermal images from, well, let's take this one here. Okay, let's take only, yeah. So this is 16-bit images, as you can see. You don't see anything, that's why, so I take the complete folder for the moment. And we simply copy these images to our webinar here. If you start with a new project, of course, I recommend to make a small program, capture image, store, save image. That's the way how we store these images also. And then you can say, okay, we want to capture the image. We load it with load cyclic, and we use the complete folder in this case. And so if we run it now, you see here, he automatically realizes, okay, this is the thermal image. That's why he automatically says, we activate the pseudo color for the display, of course. And now we can say, okay, let's say we save this, and you see also the program folder is empty because this is a new project. Only things which belong to this are here stored in this subfolder of the web Thermo image. So we say, let's say, capture file, and now we have our first small program. You can run it and you see, okay, it's moving, and that's it. Simple program, it works. So the other thing what we maybe want to have is that each time we start the software, that's also if you send us something to help you, you should say we want to have a defined layout. And of course, we made the develop GUI. You remember it's the background. And of course, he also stored the location of the camera viewer, the program editor, from everything you see here. So if you remove all the stuff, then he wouldn't show it up. So the next would be how you would start it. So you can say maybe define cycles, which executes it once. Then you can say you remember the process mode. We want to run this in process mode, or no, we want to do it always in configuration mode. And we want to use a program. In this case, we say, if we open this project, we load this one, and then we start it. That means next time we open it, we see exactly this, or more important, if you say, okay, I don't know why it's not working, I did all the programming, but it's not working. That's what we also recommend. Let's say I open a new one to show it to you. So then you simply go to this position. You remember we made this one. You simply generate a zip file. That means send zip file, and it generates this zip file. So if you send it this one to us, we have exactly the complete situation. Whatever you have programmed for this, we can unzip it, open it, and we see. I delete it because we don't need it anymore. We can open it for, or one of our support team members can open it, and he sees exactly what you have. And if you have the description, okay, I don't know how this command is working, he can simply say, let's say whatever, thermal. Here. Thermal measure. Maybe we use thermal measure. And he says, okay, you say, okay, it's not working. It doesn't measure anything here. Whatever, it's crap. Then he says, okay, you know, the position is wrong, or whatever he says. But if you know, send us this, the support engineer sees exactly the same, can do the position adjustment or adjust whatever it's needed. And he can help you for the next steps. So the important thing is for the moment that you that you think about, of course, you want to measure temperature, or you want to follow a part, or you want to read OCR on a heated element. So you have to think what is the right way to do the next step. Of course, the first step is always to find the right camera for the solution, right? If you have any questions at that position, you simply call us and we try to give you some suggestions, or you simply request from some of the manufacturers the cameras and you test it by yourself. Especially, you should always have in mind that the cameras have a different how it's called, a different spectrum where it works. So if you have a silicium sensor, normally your the wavelength is 800 micrometer. If you have indium gallium InGaAs sensors, SVR InGaAs or SVR cameras, they are more expensive by heart. So yes, maybe I've forgotten to tell you, thermal cameras are not cheap, related to normal cameras. So if you use an InGaAs camera with 1 to 2 micrometers resolution, or if you need indium antimony camera for 3 to 5 micrometers, or a gallium arsenide sensor with 8 to 40 micrometers, you will realize if it's cooled or uncooled. This is another thing you will realize. In the average, the cameras start at roughly, let's say, 2,000 euros. And if you have one of these special sensors, you need immediately something is 10 and more thousand euros. Only to have it in your back brain that these cameras are really in relation to the normal cameras not cheap. And of course, because it's the different wavelengths, it's not like a gray camera which can see what the human can see. Of course, these cameras are always perfect for these different wavelengths, and you can, if you have a look to this temperature coefficient of the part of which you are looking, you can define what is the right, what camera do you need. You cannot say, oh, I buy a thermal camera, and then you maybe see nothing because it works in the wrong wavelengths. Of course, it's like, no, it's not so easy. Of course, if you use a normal gray camera and you want to see ultraviolet light, most of the sensors don't see it. Or let's say most of the camera manufacturer add some filters in front of the sensor to cut out these wavelengths that your image capture is not disturbed. You really have to think about the wavelengths you're looking for, because if it's like, of course, it's like if you have a gray and color camera. If you use a gray camera, you cannot see colors, and if you have based on the different wavelengths, or and it's the same for the thermal cameras. You need a camera which is active or can detect the wavelengths you are using, or you have to use based on the coefficient of your surface you are looking for, the emission coefficient of the surface. There are tables in the internet. So if you go to wiki emission coefficient for thermal cameras, you will find them, and then you will also see which what is the active size of the microbolometer or the pyro electric element, and based on that you can say, okay, I need this camera, and then you mostly don't have so much options if you have some special cameras to buy them, if they are available anyway. So that that was a short I wanted to tell you, because we have it sometimes that someone tells us, oh, I have this whatever camera and I see nothing. Your software is not working. And then he explains us, okay, this is the material, this is what we want to see. And then we can tell him, yes, look to the active, look to the wavelengths and look to your camera, and you see in these wavelengths, the camera sees nothing. And then it's, of course, whatever software you have, it doesn't see anything. Maybe to round it a little bit up, and I think you have it also, I hope you have downloaded it, and if not, I recommend to download it. For example, we have these sample projects. In this case, this is a candle, and you can see if you run it. You see here the candle is burning, and we simply measure the angle of the flame, for example. You see, you have this example on your side, so you simply can open it. As you know, this is a project. You can simply open it, and then you see also here, you see in the center of the flame, it's about one whatever temperature. I cannot see it. Maybe we can enlarge it a little bit. You see it's 3,200 degrees in the center, what the camera tells us in the hotspot. And here it's only 83 degrees, and at this position it's only 30 degrees, so it's nearly nothing left over. It's only an example, but as you can see, you can combine all the tools from here. So if you want to, as you saw it of the PCB, we can track the parts. You can measure it. You could also measure the distance of the flame or the size of the flame simply by using the measuring tools. Beside of the temperature, you can use the measuring tools. And of course, you can do all the communications. You have all the communications either by PLC or over any network, or also you can write it in a text or CSV file, so that you can put it to Excel or wherever you want to do it. There are a lot of communication tools, but there is also some statistic tools which you can use to directly generate an internal statistic. As I told you, if you don't want to see our user interface, you can run the Ivision software also as a runtime in the background. Then you only transfer maybe the images and the resulting values to your main user interface for your machine, so that it's the Ivision or the image evaluation is one background task. Or if you want to control an I/O, of course you simply can add the I/O tools here, either the PLC I/O, or if you have a Profi bus or Profinet PLC, you simply can add the Profibus or Profinet to maybe control a temperature unit or whatever you need. Or of course, if you want to control temperature by heart, you can also use our temperature controller, which enables you to set a certain temperature and control that it's on that value or whatever. Or if you have resulting values which you need later anywhere in your factory, simply use the OPC way or direct the Ethernet to send out maybe the flame, the temperature of the flame or whatever, or if it's still on. And of course, what is also nice, so we started with this glue inspection. Here we made it for one customer who really does this gluing of box, does box gluing. Also at the end of the production line, the goods are placed in a box, and then they are glued with hot glue, and you can see on the temperature of the hot glue if it really works or not. If it's too cold, the glue is not working for what reason ever. Maybe the nozzle is stuck, and then you see, okay, of course this is red here. This temperature is too low. It's not working, and so on. So you can set up the tolerance values for the temperature, and based on that, of course, but this is only an example, but I think you can understand it. You can see, okay, for the machine, all the glues are okay, then you can put it out, or else you say, okay, one glue spot is not okay, maybe you deliver it anyway, and if it's more than one, you have to re-glue it. And of course, this is the development view, and of course we have also, in this case, we made a small process view, or sometimes edit this, or maybe I opened it up. Yeah, here we see it. So he simply, that's why it was not so nice. Either we close this because we don't know it, don't need it. And then we can simply start, and you see here, this is, I know the statistic data. Of course, they are not moving so much because we have not endless data inside. So only we have, maybe we can have a look to it. We have maybe a few hundred images inside. So in this case, we have these, we load the 2 images from the 2 cameras. And you see here, glue box, it's German, from backside. And here we see, okay, maybe it's I don't know, 100 images or whatever. So after 100 images, they are repeated. And if we run it in full mode, then it's very fast until we are back at the 100 images. Of course, you have it here now in the statistics, but all the data you have in the statistics, you have it directly in direct access. So we print it also here in this additional output box. Or of course, you have also the option to use this global string to send it to any, or the OPC UR to send it to any other system where you have where you have a database to store it, or your PLC which says no good or bad, or if you think, okay, 2 are bad, you can also directly use the IO commands if you have an IO, and you can set the input and outputs. So I didn't mention it because it belongs to the first seminar. If you have offline, you can have also a simulation of the IO. So you see here, someone made some examples for the input, and if we now add, for example, the output command, set output here at the very beginning, and we set it to system ready to high. Okay, that's normal, nice. Then you will see here system ready is 1, so that you can simulate it. You can test it also without the IO, because you have this simulation here. Also, you can say acknowledge result, so you can test also the complete PLC IO to the machine. And if you map the IO of a PLC to the IO command here, which we can do, so you can directly also test it for the Profinet, if you like, or you use any of the other stuff, other IO capabilities. Yes. Finally, let's see. Let's have another look to one of the other examples. I hope this is for example, impulse thermal imaging. So this takes now a little bit because he has to load all the images. So this is here on the right top, it's only that you have an idea what we are doing now. This is a wooden part, so we have one through hole, and then we have more or less deep holes, and we do an impulse to the image, and then we analyze the sequence of it. And you see here, of course, in the gray image you don't see anything because there are no holes, but due to the different heat dissipation or cooling effect, we can simply determine the hidden holes. And of course, what's possible, we could also tell you roughly how deep the holes are, but this is exactly for one wooden for a special kind of wood. So you have to do this calibration for each kind of wood you use. So it's different for oak than for, I don't know the English words, Fichte or whatever, or pine. They have a different heat dissipation. So the depth, so you get these holes always, but the depth is a kind of calibration because of the heat transfer within the wood. But it's I think it's a nice example of what's possible with impulse thermal imaging. You can see simply voids in any kind of I think this was the wood, right? Hidden cavity, yes. We saw this one. Candle, we had it, the hot glue inspection. Tracking was our first thing, I think so. This is, of course, here you see we have also, let's say, more sophisticated user interface, and you see it's very fast. So we need maybe some delay here, so that we can see something. So normally, if you have a connection to the machine, it waits until you send out the result, and then you can see it. If it's too fast, we have also an option to do some delay. So we say wait 100 milliseconds, and if you now go to process mode and we start it, now you see it's not so fast because we make after each inspection 100 millisecond delay, or we can do it also more. But here you see a lot of options you can have. It's not only possible to have these two options. For thermal imaging, we didn't make so many different user interfaces. I would show you for the end of this session a little bit more sophisticated user interface. You can do it exactly the same for the thermal imaging. There is no difference because it's the same software and you have all the options. So this is a gear inspection. And you see here, of course, this is because we are in demo mode. Each time, and I told you that in demo mode, you can capture images also from cameras, but I/O is sometimes scrambled. So if the I/O is not executed, you get here an output. So if you have a dongle or a license, you don't get this output, but we are working in demo mode. You see it here on the right bottom. But in this case, we made different menus. So we have the configuration menu as next for maybe a worker at the machine who only can adjust maybe the diameter for the gear or the number of gears or so. And there is also the option to go to the integration mode, which we this is the mode I think we saw all day long now, or the last 2 hours. And you see it's exactly the same. What I can show you also, and you saw it in the presentation, is that we have the option with the web interface. It's also available. So I can place it here. Let's wait. So you see here it's running, and You saw it in the thermal imaging for the people tracking a few seconds ago. So you can use, if you know the, okay, if you use the web address of your system, in this case, it's on the same computer, we can use the local loop interface. This is, if it's in the same computer, then you get immediately also a web interface. So we used it for though, and you can control either if you add the control buttons to it, then you can control everything, also the diameter and everything, or as you saw it at the very beginning in the presentation, here you can also simply show for maybe a supervising person the temperature, or of course for your gear inspection or for candle inspection, glue inspection, whatever you use, you can show only the resulting values of the evaluation. Or for example, here we have this hot glue seal of these are small milk box or this let's say milk, and you have on top it's hot sealed, and you see here you have a small gap in the seal, and this could be from a hair or whatever, but normally there's a print on top. Either you cannot see, you simply see the top foil, but the interesting thing is, because the heat is not working around, you see here the broken gap, and that means, oh, the seal doesn't work. This is something, whatever is printed on top, you see it because of the heat of the camera you have used. It's a thermal camera. So now I would say thank you very much for today. I hope it was somewhat interesting for you. If you have any questions, or if you work with the software and you stuck, simply think about the zip file, generate zip file, send it to us, to our support at evt-web.com, and they will help you. Maybe I can see you next time at the next webinar at the end of March. Have a nice day and a nice weekend, and take care. Bye-bye.